Hi friends, welcome back to my session, and in this session we are going to learn about Kubernetes. Here we are going to learn what is Kubernetes, where we are going to use the Kubernetes, and why most of the companies are preferring Kubernetes in order to run their high availability applications and for high transactional applications as well. So what are the advantages by using the Kubernetes? Everything we are going to discuss in this session. Okay, before doing the practical session, first of all, we need to understand theoretical part. What exactly Kubernetes is? What is the history? Where we are going to use? So I'm going to provide the document for you for your reference. Here you can find each and everything. Here, what is Kubernetes? Kubernetes is an open source. Open source means it is available on internet. Anybody can use the same. And what is the basic purpose? It is used as a container management tool. What is the purpose of container? In order to run the applications. Container is used what? What purpose? Container is used to run the applications. So Kubernetes is used to manage the containers. Okay, and at the same time it is used to automate container deployment, container scaling. Here scaling means increasing or decreasing, means increasing the resources based on the demand and decreases the resources when the demand comes down automatically. And a load balancing. Load balancing here involves the load has been shared among the backend containers. So everything, the automation process can be done with the help of the Kubernetes. Mostly for which kind of applications we are using the containers? It is mostly used for the microservices. If my application contains n number of services, then if I want to run on the container, the Kubernetes is the one of the best option in order to manage easily and accurately, and in order to maintain the application highly available, scalable, and because of so and so other reasons as well. Okay, and it is used to schedule, runs, and manages isolated containers. Isolation means separately running. There is no relation between the containers. Isolated means that will be called as isolated. It is separately running, that are running on the virtual, that may be in virtual servers, or that may be physical servers, or that may be cloud machines. It will be able to run and manage isolated containers, and it is supported by all the cloud service provider. Majorly, how many cloud service providers we have? As you know, Azure, AWS, Google Cloud Services, GCP. So these are the mostly cloud services which has been used by the companies now. And we have different cloud service providers are there. So among those, I just tell the top 3 most cloud service providers which companies are adopting. Okay, if you come to history, initially the Google developed an internal system called Brog. Later it was named as Omega in order to deploy their thousands of applications. You know, Google has thousands of applications for the users. So in order to run the thousands of applications, Google has internally developed some tool, Omega. And in 2014, the Google introduced Kubernetes, and it has a open source platform. And Kubernetes is written in which language? Google official language. Go language is nothing but Google official language. And then Kubernetes was later, it was donated to the CNCF. It stands for Cloud Native Computing Foundation. Okay, and what are the platforms we have in order to develop the Kubernetes? We have, if you think about the online platforms, we have Kubernetes Playground, Kubernetes with KAS, and Kubernetes with Kubernetes Classroom. These are the online platforms. And if you see about the cloud platform, we have the Google Kubernetes Services, GKS, where it has been available on the Google Cloud. And Azure Kubernetes Services, it will be simply called as AKS. It will be available on the Azure. Elastic Kubernetes Services, EKS, it will be available on the AWS. These are all the cloud service providers. Suppose if I want to install the Kubernetes on my infrastructure, then I have the requirement of installation tools. Here, if you want to develop single node cluster, you are going to use Minikube as an installation tool. And if you have multi-node cluster, then you are going to use Kube ADM. And if you have multi-node cluster, at the same time you want to create the infrastructure as well, you are going to use COPS. Okay, what is the difference between Kube ADM and COPS? Here, if you are thinking about the difference between these two, the Kube ADM is lightweight and will not be able to create the infrastructure. Okay, and it is mostly used for the testing purpose or development purpose, where if you think about the COPS, it will be able to create the multi-node cluster. At the same time, it will be able to create the infrastructure as well, and it is not the lightweight. Okay, so it is mostly used for the production purpose in order to meet the large application requirements. Okay, and container scale problems. What is the problem? Suppose if I have the virtual machines on my environment, with the help of the auto scaling, the virtual machines will be scaled up. And if the same scenario will come up to container, how that will be done? What are the problems when we are facing while scale upping the containers? The first thing is containers cannot communicate with each other. Means how the virtual machines will be able to communicate with each other, in the similar way the containers cannot be able to communicate with each other. So that's why, because of that reason, auto scaling and load balancing were not possible. So, and at the same time, containers are very delicate. We need to manage carefully. Otherwise, there is a chance that the container would be crashed. Okay. What are the features? If I am going to use the Kubernetes on my environment, what are the features that will be added? Orchestration. Orchestration is nothing but controlling. It will be able to clustering the number of containers running on different networks. Auto scaling. Here, if you think here, there are two types of auto scalings are there. One is virtual vertical and the second one is horizontal. Here, if you think about the horizontal, it is means it is adding another resources. Means resources adding. But coming to vertical scaling, the capacity of the resource has been increased. If you are preferring the vertical scaling, there will be downtime will be there. But if you add the horizontal scaling, because of without disturbing the existing infrastructure, it will create the another infrastructure. So that is nothing but that is the difference between the horizontal scaling and vertical scaling. And load balancing, as you know, the load balancing nothing but sharing of load among the backend containers. It is a platform independent. Here we have the orchestration feature is there, auto scaling feature is there, load balancing feature is there. It will be platform independent, means I can be able to run on any platform. That may be cloud platform, that may be virtual environment, that may be physical environment. Fault tolerance means if any pod or node is virtual machine. Here node comes under virtual machine. Pod is nothing but a small pod. Inside of the pod we have the containers. Okay, if any pod failure or node failure, there will be immediately one more node or pod will be created in order to reduce the downtime. There will be no downtime. Rollback. Suppose if any issue happens, if I have updated any recent new version, some issue has been happened. If I want to get back to my previous version, the rollback feature has been enabled for this Kubernetes. Health monitoring. First of all, if I run my environment, I need to monitor my environment. What is actually happening on my environment? Is there any issue with the containers? Is everything okay? I need to check every time. So here, by using the Kubernetes, the health monitoring of containers will be done. We can be able to monitor the container health service. If one container fails, automatically it will create another container. Batch execution. Batch execution is nothing but if you want to process the large number of commands, suppose if you think that will be commands, batch, it will be executed in a batch wise, means lot of things will be executed in a single operation, scripts. And one more thing here, in Docker, if you want to create image, means for the for image automation, what we are used, Docker image. In the similar way, here in Kubernetes, we are going to use the manifest file. Manifest is a file where we are going to place all the things which are required in order to deploy the containers. Okay, services, each and everything will be mentioned under the manifest file only. If we apply the manifest file to the cluster, automatically the things which we had mentioned in the manifest file will be automatically applied over the cluster. Okay, fine. So you will have some kind of doubt, as we have already Docker is there, so why we need to use Kubernetes? Yes, we have the Docker, and by using the Docker also we can be able to control to orchestrate the containers. But why we are using the Kubernetes? Because of the advanced features which has been supported by the Kubernetes, most companies are showing their interest towards the Kubernetes because of it has been provided some advanced features in order to orchestrate, in order to additional feature what we had discussed earlier, the additional features which has been supported by the Kubernetes. Fine. What are the things? Here if you think about the scaling, means parameters scaling, here in Docker Swarm, there is no auto scaling. In Kubernetes, auto scaling is there. Load balancing. In Docker Swarm, it does auto scaling automatically. But in Kubernetes, we need to configure it manually. Storage volume. Shares storage volume with any other container. But in Kubernetes, shares storage volume across the containers which are in the same pod. Use of logging and monitoring tool. And if you think about the Docker Swarm, for monitoring purpose, we need to use some third-party tools like ELK. But for Kubernetes, we have the inbuilt tool in order to monitoring and in order to collect the logs. Installation. If you think about the Docker Swarm, its installation is easy and fast. But Kubernetes, it will be somewhat complicated and time consuming. It will take some time. It is not that much easy to create the Kubernetes clusters. We need to take care each and everything while configuring. Okay, GUI. Here GUI not available for Docker Swarm, but it is available. Scalability. Scalability is faster than Kubernetes, but cluster strength not as robust. Okay, because of these differences, majority of the companies are showing their interest towards the Kubernetes. And if you want to see the basic structure behind the Kubernetes cluster, this is the thing. If you have the 4 missions, suppose if you select the 4 nodes is nothing but 4 virtual missions or physical missions, whatever it will be. After 4 missions, one would be master. Master is nothing but it will be controlling the rest of all nodes. And if you think in this scenario, one is the master node and rest 3 are worker nodes. Whatever the command executed by the master, the same will be executed by the worker nodes. In worker nodes, we have pods. The pods will be created. Kubernetes will have the access to the pods only. Okay. Inside of pods, we have the containers. For every pod, there must be a minimum 1 container. Okay. And it's our choice based on the load balancing. Suppose if I have 9 containers, automatically as per the load balancing law, it will be distributed 3 containers per pod, 3 containers per node, 1 pod, 3 containers, like that. In this way, the communication will happen. And if you see this diagram, if you have the Kubernetes cluster, inside of your Kubernetes cluster, what you have? You have the nodes. Inside of nodes, what you have? Pods. Inside of pod, what you have? Container. Inside of container, what you have? Your application or service which is running inside of the container only. This is the structure. You just need to remember. And if you see the architecture in master plane, master is nothing but control plane. It contains all the data. We can be able to communicate with the master plane only once we once we had put the input commands. It will be accepted to the master plane and it will be forwarded to the worker nodes. Just please have a look on it. Master plane, what are the components we have? The first one is API server. The API server exposes the API. Means if any user want to communicate with the Kubernetes cluster with the help of the API. API stands for Application Program Interface Server. With the help of the API server only, he will be able to communicate with the Kubernetes cluster. If he input the commands to the API server, it will be take forward to the further nodes. Okay, etcd cluster. Etcd cluster, it is used to store the cluster data. Kube scheduler. Here, if you think about the kube scheduler, the purpose of kube scheduler is, if I had put the input to the API server in order to create one pod, it will inform to the kube scheduler. So the kube scheduler will schedule the creation of new pod. At the same time, if I want to remove the pod, the kube schedule will take care of. And kube control manager, it is used to run the controllers. And if you think about the cloud control manager, it will be able to talk with the cloud service providers. Okay, and the node components. In node, what we have? Kube proxy. The purpose of kube proxy is in order to assign the IP address to the pods. Networking. Kubelet. It is the agent. It is the agent that ensures containers in a pod are running or not. It makes sure the containers in a pod will be running state only. And Docker engine. Container means if I want to create the containers, I need some kind of Docker container engine. Here I am going to use the Docker container. Docker is a tool which is used to create the containers. Without container engine, without the container tool, can we able to create the containers? Obviously no. So that's why on each node I need to install the Docker as well. Because of without Docker, it will be quite impossible to create the containers. Not only Docker, if you whatever the container tools you are using, you are going to deploy the similar tool on that particular nodes. Okay, fine. If you think about the pod, what is a pod? A group of one or more containers. Service. What is service? The service or application which we are going to run inside of the container. Volume. Volume is an used to store the data, to persist data. Namespace. If I want to segment of the cluster dedicated to a certain purpose, suppose I am going to use this specific purpose. If I see any node, I just let me know whether it is designed, whether it is used for the specific purpose. In order to make it, I am going to use the namespace. Okay. Replica set ensures the desired amount of pods is what's running. Replica set. Deployment offers declarative update for ports and RS. Like this. And if we working with Kubernetes, we can create the manifest file and the same will be applied to the cluster in order to bring into the desired state. And pod runs on the node and which is controlled by the master. What is the purpose of master? The purpose of master is to run the containers on physical or virtual or cloud instances. And if I want high availability, suppose if master went down because of some issue, master is nothing but also virtual machine or node. Because of some hardware issue, the master went down. Then there will be issue to the cluster. In order to avoid the same, what we will do? In order to get the high availability, we can run two masters. If any one of the master has went down, automatically the total responsibility for the cluster will be taken care by the another master which is running on the same cluster. Okay, can be multi-master for availability. Master runs control plane to run the cluster smoothly. The control plane will be runs on the master only in order to run the cluster smoothly. Components, as we had already discussed regarding the components. Okay, just ignore it. And at the same time, I'm going to share this document with you over the Google Classroom. As I already told to you, whoever are interested in these sessions, you can mention your email on the comment. Accordingly, I will add you guys to the Google Classroom. Then accordingly, what are the things I had made the notes, then you will be able to access it. Okay. And mostly this is all about the Kubernetes. We just cover the basics only. If you work on the practical session, then only you will get some kind of knowledge. Okay. Then we will meet up in the next session with the practical session on Kubernetes and how we are going to use the Kubernetes on Azure as well. That will be called as AKS, Azure Kubernetes Service. Okay. Okay guys, hope you guys enjoy the session. We will meet up in the next session with the new topic. Until signing off, thank you for joining the session. Bye bye.